भी कराई होंगी, तो बाइक वाला, और काफी लोगों ने कार भी चलाई होगी। तो आप लोगों ने कभी यूज किया है सिंथेटिक लुब्रिकेंट इन योर कार और बाइक? यस। नहीं, इट्स नॉट लाइक दैट। सिंथेटिक लुब्रिकेंट क्या रहता है कि अगर आपकी कंडीशन चेंज होती रहे, ठीक है, तो वहां पे ज्यादा फर्क पड़ता है। लाइक आप अहमदाबाद या गुजरात में गाड़ी ड्राइव कर रहे हो तो कोई दिक्कत नहीं है। बट इफ यू आर गोइंग जम्मू कश्मीर, श्रीनगर, उत्तराखंड, हिमाचल, वेयर द टेम्परेचर इज क्वाइट लेस, अबाउट 10 डिग्री, तो वहां पे आपका सिंथेटिक लुब्रिकेंट ज्यादा बेटर काम करेगा, क्योंकि डिफरेंट वेरिंग कंडीशन होती है। ठीक है, जैसे मैंने आपको एग्जांपल दिया कि आपका, जैसे आप जहाज उड़ा रहे हो, हेलीकॉप्टर है सपोज दैट, एंड यू आर यूजिंग आईसी इंजन बेस्ड हेलीकॉप्टर, ओके, एंड एट द ग्राउंड टेम्परेचर अबाउट 50 डिग्री सेल्सियस, लेकिन जैसे आप 11-12 किलोमीटर ऊपर जाएंगे, तो वहां पे टेम्परेचर अबाउट -10 -20 डिग्री सेल्सियस में पहुंच जाता है। वहां पे टेम्परेचर की कंडीशन बहुत ज्यादा चेंज होंगी। तो वहां पे आप बेस ऑयल यूज करेंगे, दैट विल नॉट वर्क। ओके। हेलो। सो वहां पे आपको सिंथेटिक लुब्रिकेंट की जरूरत पड़ती है। हाँ, टेम्परेचर वेरिंग कंडीशन है, लाइक आपकी गाड़ी हाई परफॉर्मेंस है, तब हमें सिंथेटिक, हाँ, बट सिंथेटिक लुब्रिकेंट कॉस्टली भी बहुत होता है, बिकॉज इट यू टू स्पेंड लॉट ऑफ टाइम। उसको बनाने के लिए बहुत सारी R&D लगती है, इंफ्रास्ट्रक्चर लगता है। तो ये थोड़ा लेट इन्वेंट हुआ था सिंथेटिक लुब्रिकेंट। ओके, हाँ, बट इन एनी केस, अगर somebody say that which lubricant is better, definitely synthetic lubricant is better, but it is not always cost effective. Okay, so that's why I am discussing here. So some type of synthetic lubricant, polyalpha olefin, synthetic esters, so they are made in the ओके, सो वो सब लैब में सिंथेसाइज होते हैं, दे आर द सिंथेटिक लुब्रिकेंट, दे आर सिंथेसाइज इन द लैब, दे आर मेड इन द लेबोरेटरी बेसिस। ओके, we manufacture this in our lab. So one example is polyalpha olefin synthetic ester, polyalkyl glycol, phosphate esters, alkylate naphthalene, silicate ester, ionic fluids. So these are some example of the ionic fluids. Okay, we use, so they are the, and type of these means type of lubricant also depend on the application. Like if we are using this in automobile, then we will prefer the polyalpha synthetic ester. If you are using at high performance, high altitude, then we have used high altitude, then we have to use high altitude synthetic lubricant. Like ionic fluids are okay when there is chances of rust. We prefer the ionic lubrication. Silicate esters are the one of the example. So advantage of the synthetic lubricant are the following: measurably better low and high temperature viscosity performance, better chemical and CA stability, improved fuel economy. So there are some advantage of the synthetic lubricant. It has measurably better low and high temperature viscosity performance. So it is a better chemical and CA stability, improved fuel economy in certain engine configuration, better lubrication on cold start, longer engine run. सो दे आर द सम एडवांटेज कि इनका क्या होता है कि लो एंड हाई टेम्परेचर विस्कोसिटी परफॉर्मेंस होती है, ठीक है, केमिकल स्टेबिलिटी ज्यादा होती है, इम्प्रूव्ड फ्यूल इकोनॉमी इन सर्टेन इंजन कॉन्फ़िगरेशन, so it provides a better lubrication, cold start, longer engine life. Okay, so there are some advantage ki it can vary at different temperature levels. Okay, so chemical stability is better, like you can use at high pressure. Like I have given the example when the two gear teeth are in mesh. One student want to join, let them in. Okay, I as I told you, the complete load is transferred by only two gear teeth. Okay, to carry such a high load or high pressure, we require some certain good lubricant. So it's provide a better lubrication, cold start, longer engine life. So these are some advantage. So disadvantage of the synthetic lubricant are the following: potential decomposition problems in certain chemical environment. Synthetic do not hold lead in suspension. Okay, and one more thing last is they are the costly. Okay, and synthetic oils are not recommended in automotive rotary engines. Okay, one more thing that it do not have a good quality suspension like as well as mineral oils have. So just cautionary advice when the engine is run on loaded fuel. So solid lubricant. As I told you, there's a various application. We cannot prefer air as a lubricant, gas as a lubricant, and gas as a lubricant, and means liquid as a lubricant. So we have to go for the graphite and molybdenum disulfide. Actually, if you have seen the various example that we have a lifelong running, if you have seen the example of your hard disk, okay, nowadays various kind of hard disk like we have rotational hard disk in our laptop, in our desktop. Nowadays there are some hard disks are developed like they are called SSD hard disk, solid state drive. So now question come like why we use like certain condition, like if your desktop fan, okay, that is running desktop fan, and आपके there is a one more desktop fan that you have in desktop, like in our household application there is a fan. When we cannot do proper lubrication, okay, what we do, we add a graphite and molybdenum layer coating on the surface, okay, that provide a good insulation. So graphite and molybdenum disulfide are the predominant minerals used as a solid lubricant. In the form of dry powder, these materials are effective lubricant additive due to their laminar structure. The laminar orients parallel to the surface in the direction of motion. So these are the some solid example of the solid lubricants. So as I told you, the application like our household fans, certain moving electronic component, we prefer the solid lubricant. We use a graphite coating or molybdenum disulfide coating on the outer surface. And in certain cases like our IC engine, we also use the graphite coating inside the cylinder piston engine. Okay, so cylinder piston are in the contact with the graphite and molybdenum disulfide coating, so that runs between them. So the components that are the graphite useful solid lubricant include the boron nitride, polytetrafluoroethylene, calcium fluoride, serum fluoride, and tungsten disulfide are a typical example. So graphite solid lubricant example graphite. There are some example the graphite, molybdenum disulfide, boron nitride coatings are on the cylinder piston engine where the temperature is quite high. So PTFE coating is also used. PTFE coating we use in our hard disk, and their application method are various cases. Self lubricating composite are also used. So there are some example of the solid lubricant. So application of these lubricants vary, like in certain cases we do not have option of the lubrication except solid lubrication. Okay, so molybdenum disulfide is various variety used as I have given you the example. Boron nitride is a high temperature lubrication. PTFE, like temperature is low, we also use the PTFE lubrication. Like if you have seen the small motor, like a small device motor that is used in our electronic instrument that runs on PTFE lubrication. So and one more thing that it also depends on the application method. Okay, which application you are using this lubricant. Okay, that is also depend. But one more thing I want to add: if your speed is very high, then liquid lubricant are the best option. So that's why in case of IC engine, you will see the between the gear teeth and inside the engine, we prefer the liquid lubricant, not the solid lubricant. When we do not have option that the power consumption is quite small, we prefer the solid lubricant. However, the friction coefficient in the solid lubricant is maximum. Friction coefficient in solid lubricant is maximum. Then we go for the liquid lubricant. It has the quite less. After that, the other class of lubricant that the gas lubricant, they have the minimum amount of friction. For the very high speed engines, we prefer the gas as a lubricant. Okay, nitrogen, generally nitrogen are used as a lubricant, and sometimes air also used as a gas lubricant. So typical application, like I have already discussed that sometimes we also prefer the ceramic coating type of the lubricants. So nowadays standard change. Previously we used the general lubrication. Nowadays, so nowadays texture also used in the lubrication. Texture decrease the amount of fuel. Okay, texture decrease the amount of friction inside the engine. So reciprocating motion, a typical application is a sliding or reciprocating motion that require lubrication to minimize the wear edge. For example, in the gear and chain lubrication, liquid lubrication will squeeze out when the while the solid lubricants don't escape and prevent for the fretting, corrosion, and galling. Ceramic, another application of is for case where the chemically active lubricant additive have not been found for particular surface, such as the polymers and ceramic. So typical application is a sliding where we prefer, and ceramic coating also we use in polymer. So application high temperature. Graphite MOS2 exhibits high temperature and oxidizing atmosphere component where the liquid lubricant typically will not survive. Typical application include the fastener which are easily tough tightened and unscrewed after a long stay at high temperature. Extreme contact pressure laminar structure orient parallel to the sliding surface, resulting in the high bearing load combined with a low shear stress. Most applications in the metal forming that involve the plastic ramification will utilize the solid lubricant. So Teflon or PTFE. Teflon is typically used as a coating layer on cooking utensils. One more thing that if you have seen that the nowadays you can see we have a non-sticky utensils. So whatever the thing that non-stick utensils are generally made of aluminum alloy. We aluminum is used aluminum copper alloy. Because aluminum we use because it has a better thermal conductivity and copper also have a better thermal conductivity. In the case of Teflon, in the case of Teflon, we in the case of non-stick surface, we add a coating of Teflon. Okay, so it do not have any effect when the temperature increase. Okay, it do not anything stick on the Teflon coating. Teflon is typically used as a coating layer on cooking utensil to provide a non-sticky surface. Its usable temperature range up to 350 degrees Celsius and the chemical inertness make it is it a useful additive in special cases. Under extreme pressure, Teflon powder or solids have has a little value as it is soft and flow away from the area of contact. So inorganic solid, the graphite hexanol, boron nitride, molybdenum disulfide, tungsten disulfide are the example of materials that can be used as solid lubricants, often to very high temperature. The use of some such materials is just sometimes restricted by their poor resistance to oxidation. Molybdenum sulfide can only be used up to 350 degrees Celsius in air, but 1100 degrees Celsius in reducing environment. Okay, so metal alloy also used as a solid lubricants. Metal alloy composite and pure metals can be used as grease additive or sole constituent of the sliding surface. Bearing, cadmium, and golds are used as a plating surface, which gives them good corrosion resistance and sliding property. So when we are using the solid lubricant, we have to consider the sliding property. Lead, tin, zinc, and bronze various alloy also used as a sliding bearing. Their powder can be used as lubricate sliding surface. So I just told you, like solid in the solid lubricants, when the sliding occur, these materials are quite soft. Okay, due to softening, they provide the elasticity property to the moving surface. Okay, due to that there is a friction less. If you are using a steel, okay, steel, then it cannot provide good sliding surfaces. It will be worn out. Okay, so these are the some advantage of the solid lubricant that we prefer. Cadmium gold are used for plating surfaces which gives them good corrosion resistance and sliding surface. Lead zinc alloy and the various bronze alloy are used as a sliding surface, or their powder can be used to lubricate sliding surface alone. So parameter affecting the performance of lubricant. So these are the parameters that affect the lubricant under given condition. Type of motion, speed, temperature, load, and operating environments. So these are the properties that affect the performance of lubricant. So how the type of motion? As I've described, if it is a sliding motion, if it is a rotating motion, then we have to consider. If it is sliding motion, then we have to consider different lubricant. If it is rotating motion, then we have to find out the Sommerfeld number. Okay, as I told you, speed is a very important parameter when we are selecting a lubricant. Speed, like I told you that when speed is low, we prefer the solid lubricant. If speed is little bit high, when it's higher than the higher, if we increase the speed, then lubricant change, state of lubricant change according to speed. If it is a speed is quite increased, then we use the grease. So you can see the example of the solid lubricant like in our household application where we have refrigerator and air conditioner, we use the solid lubricant. Okay, so solid lubricant. Then again, second is the third is the temperature we prefer, then load and operating environment. So speed on increasing speed, state of lubricant becomes solid, semi-solid to liquid. First it is solid, then comes to semi-solid, then it comes to liquid, and after liquid it becomes the gas as the speed is increased. On the increasing speed, the state of lubricant also change. So load also change. On increasing the temperature, the condition of lubricant also change. Loading condition also change. Operating environment also change. Additives also change. Okay, so load how it vary. If you have seen that in that Sommerfeld number, so load change the lubrication. Okay, so Sommerfeld number. So load is very important parameter when we are characterizing the lubrication zone. Temperature is very important. So if you will see the ISO VG46, ISO 32, Servo 46, similar 46. So 46 is the viscosity number. If you will see the fluid viscosity is exponential function of the temperature. On increasing the temperature, viscosity exponentially decreases. So operating environment is also there and additive also there. So types of motion. So first parameter of the tribological system involve the type of motion. Motion may be sliding, which would require the hydrodynamic lubrication theory for its analysis, or rolling, in which case EHD lubrication theory would be applied. Combined sliding and rolling is also a possible form of motion, and certain rolling environment bearings, including the tapered roller bearing, sliding in the rib area can occur in this bearing, but the rolling element roll on the raceway surfaces. Some lubricant chemistries are effective in sliding contacts but do not perform as well as in the rolling contacts. So speed is the second important parameter on the tribological system. The Stiebeck curve is a graph showing a relationship between the coefficient of friction, the dimensionless number Zn by P, where Z is the dynamic viscosity, N is the speed, and P is the load per unit of projected area. According to this graph, there is an optimum speed for the lubricated contact. Knowing the speed of the contact, a lubricant can be selected. Optimum physical. So Z and P is a very important parameter that is from the Stiebeck curve. So where Z is the dynamic viscosity, N is the RPM, and P is the projected load. I think I should finish my presentation here. If you have any queries related to what we have discussed, please let me know. Yes. If you have any query, I will share these slides with you. Okay, if you have any query, please let me know related to this topic. Yes. I think I should stop it here now. Rest we will discuss later. Okay, thank you very much.